Custom comparison for built-in containers. In my code there's numerous comparisons for equality of various containers, list, dict, etc. The keys and values of the containers are of types float, bool, int, and street. The built-in equals and not equal worked perfectly fine. I just learned that the floats used in the values of the containers must be compared using a custom comparison function. I've written that function already. Let's call it a proxycall, and assume that it takes two floats and return true if they are judged to be equal and false otherwise. I prefer that the changes to the existing code are kept to a minimum. New classes, functions, etc. can be as complicated as necessary. Example. The dict1 not equal dict2 condition needs to be rewritten so that any floats used in values of dict1 and dict2 are compared using a proxycall function instead of __eq___. The actual contents of dictionaries comes from various sources, parsing files, calculations, etc. Note, I asked a question earlier about how to override built-in floats equal. That would have been an easy solution, but I learned that Python doesn't allow overriding built-in types __eq__ operator. Hence this new question.
The only route to altering the way built-in containers check equality is to make them contain as values, instead of the originals, wrap values, wrapped in a class that overrides __eq__ and __ne__. This is if you need to alter the way the containers themselves use equality checking, e.g. for the purpose of the in operator, where the right-hand side operand is a list, as well as in containers methods such as their own __eq__ type x .__eq__ y is the typical way Python will perform internally what you code as x == y. If what you're talking about is performing your own equality checks without altering the checks performed internally by the containers themselves, then the only way is to change every con1 == con2 into, e.g., same, con1, con2, value _same, where value _same is a function accepting two values and returning true or false like == would. That's probably too invasive. WRT, the criterion you specify. If you can change the container themselves, i.e., the number of places where container objects are created is much smaller than the number of places where two containers are checked for equality, then using a container subclass which overrides __eq__ is best. E.g. with same being as I mentioned in the second paragraph, and so forth for other container types you need, then wherever you have, e.g. change it into. And be sure to also catch other ways to create list objects, e.g. replace with and with and so forth. Yeah, I know, what a bother, but it's a core principle and practice winky face of Python that built-in types, be they containers or value types like e.g. float, themselves cannot be changed. That's a very different philosophy from e.g. Ruby's and JavaScript's, and I personally prefer it, but I do see how it can seem limiting at times. Edit, the specific request seems to be, in terms of this answer, how do I implement same for the various container types, not how to apply it without changing the == into a function call. If that's correct, then e.g, without using iterators for simplicity. Note that this applies to values, as requested, not to keys. Fuzzing up the equality comparison of a dict's keys, or a set's members, is a real problem. Look at it this way. First, how do you guarantee, with absolute certainty, that same value, A, B, and same value, B, C, totally implies and ensures same value, A, C? This transitivity condition does not apply to most semi-sensible, fuzzy comparisons I've ever seen, and yet it's completely indispensable for the hash table-based containers, such as dicts and sets. If you pass that hurdle, Then the nightmare of making the hash values somehow magically consistent arises. And what if two actually different keys in one dict map to equality in this sense with the same key in the other dict? Which of the two corresponding values should be used then? This way madness lies, if you ask me. So I hope that when you say values you do mean exactly values and not keys.
Beautiful chat. This is Lloyd.